Wagwan, my GCSE science students, stop scrolling. You need to stop scrolling right now because we're going to go through series circuit, okay, for your GCSEs. Now, on your screen, you can see a series circuit. You have two bulbs and they're connected in series. How do we know that they're connected in series? Because there is one loop and there are no branches, okay? Now, the other thing that you need to know about a series circuit is that if more bulbs are added to this circuit right here, what will happen is that the other bulbs will become dimmer. All right. And the other thing that you need to know about series circuit is that if one bulb becomes damaged, okay, no current flows because there's no way for the electron to move around in the circuit. All right, the pathway has been damaged, no current flows. Okay, good. Now there are three rules you need to know about a series circuit. All right, get your flashcards ready because we're going to fling these on your flashcards. Man, shoulder for your fling. Sorry. I'm GCSE Science Ball said that no singing. Anyways, for my non-Caribbean people that are watching this, fling means to throw, all right, or dash, all right. So here goes. First rule, current is the same everywhere in the series circuit. All right, put that on your flashcard straight away. Next rule is that for potential difference, it is shared across all the components and it is shared evenly if those components are the same. And the final rule is that resistance is added. Make sure you know these three rules. They may not ask you the exact rules, but you need to know how to apply these rules. All right, pause to add this to your flashcard. Now let's apply these rules. Now first one, we said that the current is the same at all points. So what's the reading at A2 and A3 if A1 is 0.5? The rule is very simple. Current is the same at all points. All right. So this has to be 0.5 amperes. And this also has to be 0.5 amperes. All right. Good. Make sure you know why it is 0.5 because you have the same number of electrons going around. All right. Next up. Next rule, it says that potential difference is shared. Okay, so what is the reading on the voltmeter V1 if the reading on V2 is 9 volts? So V2 is 9 volts. Good. V3 is 3 volts. Remember, it is shared. So 9 add 3, that has to be 12 volt. All right, because that 12 volt has to be shared here and has to be shared at that point there. All right, good. Now we're gonna bring all the rules together. All right, but okay, so let's go through these questions. All right, so it says that to find the total resistance on the following circuit, remember the rule, resistance is added. All right, so what we have here, it is a series circuit. All right, ignore the voltmeter for now, but it is a series circuit. So what's going to happen? My total resistance is going to be equal to R1 plus R2 plus R3. So we have R1, which is 5 ohms, R2, which is 10 ohms, and R3, which is 9 volts. Okay, so that is 19, so that's going to be equal to 24 ohms. Okay, good. Now it says here you need to find the current in the ammeters if the current at R3 is 2 amperes. So what we're saying here, the current flowing at this point is 2.0 amperes. Remember what the rule said about current? Current is the same at all points. That means that at ammeter 1, A1 has to be also 2 amperes. And A2 is also going to be 2 amperes. Okay, good. Then it's now asking us to find the voltage on R1, R2, and R3. Now to find voltage, you know that V is equal to IR. Okay. Now, do we know the current? All right, we're doing R1 first. So we're doing at R1, so V is equal to IR. So we know that the current is 2. And we know that the resistance at R1 is 5. Therefore, it's going to be a total of 10 volts. Now let's look at R2. Again, we're still going to use that formula there. V is equal to IR. Okay, good. So Current is still going to be the same, and that's now going to be 20 volts. Good. And at R3, it's going to be 2 times 9, which is equal to 18 volts. All right. Good. So you have to remember to apply all the rules. All right. So our answers are all there. Everything is correct here. Okay, so let's have a look at this question. We're bringing it all together in another question. So we need to find the total resistance in this circuit. Okay. So to find the total resistance, it's going to be equal to R1 plus R2. Okay. So we're going to add both of those. It's going to be 6 ohms plus 2 ohm, and that's going to be equal to 8 ohm. Okay, good. Now the next question is going to ask us about the current flowing through R1 and R2. So what's the current flowing? So we know that current, so now we're looking at B, we know that V is equal to IR, okay, which therefore means that I is equal to V over R. Now, do we know V? Yes, we know that the total voltage in this circuit is 4, okay, and we know the total resistance is going to be 8, therefore our current is going to be 0.5 amperes. Okay, good. So flowing through R1 and R2, the current is going to be the same, 0.5 amperes. All right, good. And then next up now we need to find the voltage across here. So if we put a voltmeter there, what's the voltage across R1? And if we put a voltmeter there, what's the voltage across R2? So let's look at the voltage across R1. Let's call that V1. So we know the current, which is 0.5. We know the resistance, which is 6. So 0.5 times 6, that's going to be equal to 3 volts. Good. Without calculating, we know that this has to be 1 because they need to add up to give us 4. But let's still do the calculation. All right. So for V2, this is question D. It's going to be 0.5 times 2, which is going to be equal to 1 volt. They need to add up to give us back the 4 volts. Okay. All right. Thank you for watching. Please make sure that you subscribe if you're coming over from TikTok, or if you just came upon this video, please ensure that you subscribe. I'm out.